Yeah, so I think we can get started. Just a heads up to all of you in the very beginning. I'm not that well today, so in case if you're not being able to hear properly or understand, do let me know once, okay, so that I can get it uh, revised once more. All right, just in case if there are some issues, just don't hesitate to let me know. I might be a little slow today. Okay, so let me share the screen. So, in the last class, we were discussing some questions on differential equations, right? And this was the last one at which we stopped. So, did anybody give this a try after this step? Anyone? Okay. If not, then maybe I should discuss this first, and then we will go into the next part of our discussion, which will be the second order linear differential equations. Okay. So let me just take a look at this question once more that we were discussing. So this was the question that we considered solution to this differential equation, which is this. Then limit t tends to infinity, yt is how much? And we were first of all trying to solve this differential equation, right? So I'll just take this last step from here. How much we had done? We had covered up till here. So anyone, any questions up till the part that we have discussed? How we have reached up till this step? Is this fine? Is this part okay with all of you? Okay. So if there are no questions on this, then let's continue. So this will be what? Minus half if you complete the solution. Minus half log of mod y plus 1 by 3 log mod of y plus 1 plus 1 by 6 log mod of y minus 2 is equals to minus t plus 6, right? And if I combine all these logs, I can write it in this way. So this will be log of y minus 2 raised to the power 1 by 6, y plus 1 raised to the power 1 by 3, divided by y raised to the power half is equals to minus t plus c, right? Okay. So that means this can be written as y minus 2 to the power 1 by 6, y plus 1 to the power 1 by 3 divided by y raised to the power half is equals to e raised to the power minus t into e raised to the power c. Correct? So this I can write down e raised to the power c. You can write it as some a times e raised to the power minus t. Right? So this is your general solution. Correct? Understood, everyone? Agreed? And now, if we come back to the question once more, we are also given this condition, right? That y of 0 is equals to y naught. That means we need to find out the particular solution. That means I'll put t equals to 0 and y equals to y naught in this equation. So what are we getting? A is equals to y naught minus 2 raised to the power 1 by 6, y plus 1 raised to the power 1 by 3, divided by y naught raised to the power half. That means what is the final solution that we will have? Y minus 2 raised to the power 1 by 6, y plus 1 raised to the power 1 by 3 divided by y raised to the power half is equals to e raised to the power minus 3 into this term. Okay, so this is your particular solution. All right. And now the question was, we want to find out limit t tends to infinity yt. So this, even without rearranging, I can find the limit, right? So if I take limit t tends to infinity on both sides, I will be getting the answer. So if you take the limit on both sides, so can anyone tell me if I start with the RHS, what would be the RHS? Anyone? If you take limit t tends to infinity, what will happen to this component? What will happen to this component?
It will tend to zero.
It will tend to 0. That means the entire RHS will become 0. So if the entire RHS is becoming 0, then the numerator on the left hand side should ideally be 0, right? So that means under limit t tends to infinity, y minus half raised to the power 1 by 6, y plus 1 raised to the power 1 by 3 have to be 0. Correct? Okay. Is it making sense to all of you? Any questions? So that means when t tends to infinity, this is the condition that will hold. So from here, can we solve for values of y? The value of y when t tends to infinity?
What the factors have to be zero. So, y would be 2 or y would be negative 1.
2 or, sorry, what was the other value?
Negative 1.
Negative 1. So 2 or minus 1. So which option is matching? Yes, can anyone take a guess? So which option is matching?
C.
C. C.
2.
Why not B?
Because the
Because,
range
sir,
is
because of
defined
the
on
range.
y.
Yes, absolutely. It's given in the question that the value of y will always lie between 0 to 2, or y is essentially positive. So that means y equals to minus 1 is not possible. So the only correct solution that you will have over here is y equals to 2. Okay. Others, is it fine with all of you? Got it? Making sense? Any questions? All right, perfect. So if this is more or less fine with all of you, so now let's begin with the next part of our discussions, which is the second order linear differential equations. All right. So let me just pull down the heading. So just to compare over here, if you recall that how did we define the first order linear differential equations? The general format, I mean, first order linear differential equation. You basically had a structure like this, right? dy by dx plus p times y is equals to q, where p was a function of x and q was also a function of x. Correct? Now over here, when we talk about the second order, so you will have the second order term as well. So the second order linear differential equation will be d2y by dx2 plus p1y, sorry, p1 dy dx plus p2y is equals to q. Okay, where p1 is some function of x, p2 is also some function of x, and q is also some function of x. Okay, got it? So this is basically, so you have an additional second order term in the expression, and that makes it a second order linear differential equation. Okay. So if you remember that how we solved the first order differential equation, we first tried to define an integrating factor, and then we multiplied that integrating factor with the differential equation to solve it out, right? So that was the solution technique that we had for the first order linear differential equation, right? In a similar way, let us look at that what will be the solution technique for the second order differential equation. All right. So starting off with the solution technique, how we are going to solve these kind of second order linear differential equations. So the first thing that we will do is that you will put the RHS as 0. That is, if you'll put Q equals to 0, and then you will solve the remaining differential equation, which will be d2y by dx2 plus p1 times dy by dx plus p2y is equals to 0. So you put your RHS as 0 and try to solve out this reduced differential equation. Okay. So just one terminology that we need to know over here is that, so for any differential equation, in this case, where the RHS is 0, we call it as a homogeneous equation. Okay. And whatever solution we will get from here, so we will denote the solution of the homogeneous equation as y subscript c. Okay, this is known as the complementary function. Okay, this is the first step. Number two, in the original equation, you will put all the derivatives to zero. That means all the second order derivatives and the first order derivatives, both of them you will put equals to zero and find the value of y. Okay, this value of y that you will find is known as the particular solution, which is denoted by y subscript t. And finally, the third step would be the final solution is y is equals to yc plus yp. Okay, so these are the three steps of solving your second order differential equation. So I'll go through them once more. First of all, you will put your RHS as 0 and solve the homogeneous equation. The solution that you will get for this is the complementary function yc. Step number 2, you will put all the derivatives to 0 and you will find the value of y, which is known as the particular solution denoted by yp. And then the final solution will be y equals to yc plus y. Okay, so these are the steps that we need to follow in order to get the solution of a second order differential equation. Okay, now let me just go a little bit more in details as to how we'll do all these one by one. We haven't yet discussed that. So let's say that to start off, let me begin with the easy part. Let's say I'm talking about, so what is my original differential equation? The second order differential equation that we are talking about is this. So let's say I start with point number 2. So the order is not that important over here. So let's say I want to find my YP. Okay. So if I go by the description that we have mentioned, for finding out my YP, what do I need to do? I need to put all the derivatives as 0 in the differential equation. Correct? So if all the derivatives are 0 in the differential equation, what do I get? P2y is equals to Q. That means my particular solution yp will be q upon p2. Okay, is this part making sense to all of you? Any questions from anyone? Okay, so moving on to finding out the complementary function. If I have to find yc, so for that what do I need to do? I need to put my q equals to 0. So if I put my q equals to 0, then this is my differential equation. Right? And I need to solve this differential equation. Right? Now, how do we start with this? Now, there's a very simple technique to go about this. Let me just write this down step by step so that you all understand this. So the idea says that we need to begin with a trial solution. Okay, so let me just write this. You will begin with a trial solution as y equals to, let's say, e raised to the power mx, where as of now m is unknown. What do I mean by this? That why am I saying that this is a trial solution? I'm simply saying that the solution of this differential equation can be of the exponential form. Okay, that is what we are saying. That this is a trial solution to begin with, where m is unknown. We are just saying that it is an exponential form where we need to find out what is the value of m. Okay, now how is this helping us? So let me just take you through a few more steps to understand this better. So if I'm saying that, so let's say I denote this homogeneous equation by star. So if I'm saying that y equals to e to the power mx is a solution of this differential equation star, that means what? If I replace y equals to e to the power mx in this differential equation, the equation should be satisfied. By satisfied means what? LHS will be equals to RHS, right? So as y equals to e to the power mx is a solution of star, that implies that the second derivative of e raised to the power mx plus p1 times the first derivative of e to the power mx plus p2 times e to the power mx will be 0. Now, can anyone quickly tell me what will be these two derivatives, the first and second derivatives?
M square E mx power mx.
Second derivative is m square emx, right?
Ah,
And what about the first one?
M into e power mx.
So p1 into,
P1, yeah, P1 into e power mx.
okay, is it fine with all of you? Making sense? So from here, what I can do? I can take a e to the power mx out common. So you will have m square plus p1m plus p2 is equals to 0, right? We know that the exponential term cannot be 0. So that means m square plus p1 times m plus p2 is equals to 0. Now, what is this? So from this equation, I need to find out the value of m, right? Or rather, this is a quadratic equation in m, correct? So can anyone tell me that given this quadratic in m, what will be the value of m?
Quadratic formula.
Sorry, can you repeat once more?
We can use the quadratic formula.
What is that?
So
What's the
minus
formula?
C1
Yes,
minus C1 plus and
plus
minus P1 squared minus 4 P2 divided by 2.
correct. So from here you will get two possible values of m, and let's say I denote them by m1 and m2. Okay. Now, if you remember that for a quadratic, the nature of the solution depends upon the value of this part, the square root part, which is known as the discriminant, right? Does anybody remember the cases of the discriminant? What are the three possible cases that we can have?
If it's greater than 0, then there is two distinct roots, real roots. If it's equal to 0, there is one real root with the multiplicity of 2. And if the the discriminant is less than 0, then we would still have two roots, but they'd be complex in nature.
Correct, exactly. So, what exactly will be the nature of this M1 and M2 that we are talking about depends upon the value of this discriminant D, right? Correct. So that means based on the value of D, there are three possible cases. Correct. Number one, if your D is positive, then roots are real and unequal, right? Correct. That means M1 and M2 both are real, but they are not equal. Okay. So the two possible values of M that you get are M1 and M2. So what would be the corresponding solutions? E raised to the power M1x and E raised to the power M2x. Correct? Two possible answers depending upon the value you choose for the solution. Correct? And what we generally do, I'll just show you in a minute in case if it is confusing, that we take the solution as a linear combination of both of them. Okay, so this is a linear combination. Linear combination Q because C1 and C2 are scalars. Okay, let's try to check this. If so, does this make sense? Anyone who is not sure that how am I writing this? That this will also be a solution. Anyone? So the initial starting point was that so on solving the quadratic for m, you are basically getting two possible values, right? M1 and M2. So that means typically I can have the solution as e raised to the power m1x or e raised to the power m2x, right? Now I'm saying that we basically club these two solutions and say that this is the solution or the complementary function. Okay, now let's try to check this argument. So what am I saying? That so the original proposition that we are trying to discuss over here is that if e raised to the power m1x and e raised to the power m2x is a solution of y double dash, plus P1 y dash plus P2 y is equals to 0, then C1 times e to the power m1x plus C2 times e to the power m2x is also a solution. Correct? This is what I just said. Now let's try to understand this a little bit mathematically, if that is more clearer to all of you. So when I'm saying that e to the power m1x is a solution, so that means it will satisfy the differential equation, correct? Right? Agreed? So if you replace this, what will happen? M1 square e to the power m1x plus P1 m1 e raised to the power m1x plus P2 e raised to the power m1x is equals to 0. Correct? Similarly, e raised to the power m2x is a solution, right? So that means m2 square e raised to the power m2x plus p1 times m2 e to raised to the power m2x plus p2 times e raised to the power m2x is equals to 0, right? Let's say I call this as my first solution and this is my second solution. So what is the proposed solution that I am talking about, or the new solution? C1 into e raised to the power m1x plus C2 e raised to the power m2x, right? So if this is a solution of this homogeneous differential equation, then LHS should be equals to RHS, right? On replacing it. So let's try to work with the LHS. So the LHS will be what? If you replace it, the second derivative of this plus P1 times the first derivative of this plus P2 times y, correct? So if we just try to solve this, what we are getting? Second derivative will be C1 m1 square e raised to the power m1x plus C2 m2 square e raised to the power m2x, right? Plus P1 times C1 m1 e raised to the power m1x plus C2 m2 e raised to the power m2x, right? Derivative completed plus P2 times C1 e raised to the power m1x plus C2 e raised to the power m2x. Okay, is this fine with all of you up till this step? Any questions? So if now I just rearrange this a little bit, if I take all the terms with C1 as common, so what will this happen? M1 square e raised to the power m1x plus m1 e raised to the power m1x plus e raised to the power, sorry, we have missed a couple of things. P1 plus P2 e raised to the power m1x, right? C2 times m2 square e raised to the power m2x plus p1 m2 e raised to the power m2x plus p2 e raised to the power m2x. All right. Now, what is this part? If you look at this is your equation 1, right? The LHS of equation 1. So this is 0 from equation 1, right? And this part is also 0 from equation 2. Correct. So that means if you solve the LHS, this will be equals to 0 and RHS. So hence you can say that C1 e raised to the power m1x plus C2 e raised to the power m2x is also a solution. Okay. Is it making sense to all of you? Any questions, anyone? Any doubts?
স্যার বলছি আমরা ডিসাইড কিভাবে করছি ই পাওয়ার এমএক্স কেই সলিউশন হিসেবে ধরবো, মানে ট্রায়াল সলিউশন তো
So,
ওই রকমই স্ট্রাকচারটা যে হবে সেটা কিভাবে আইডিয়া আসছে?
আইডিয়াটা এখান থেকেই আসছে আমার, যে কি এক্সপোনেনশিয়াল ফাংশনের সব ডেরিভেটিভস এক্সিস্ট করে, রাইট? ফার্স্ট অর্ডার, সেকেন্ড অর্ডার, থার্ড
হুম,
অর্ডার, ফোর্থ অর্ডার,
হুম,
তাই তো? তার
হুম।
মানে তোমার সেকেন্ড অর্ডার এর সলিউশনটাকে আমি এক্সপোনেনশিয়াল ফর্মে লিখতে পারবো। সেখান থেকে আমার আইডিয়াটা আসছে, মানে এক্সপোনেন্ট, দ্য ফ্লেক্সিবিলিটি অফ দ্য এক্সপোনেনশিয়াল ফাংশন gives you the idea or the initial starting point to decide যে কি ওটা দিয়ে করলে আমার সুবিধা হবে।
আচ্ছা, ডিফারেন্ট ট্রায়াল সলিউশনও তো এক্সিস্ট করতে পারে, তো তার জন্য তো ওয়াইসি টা আলাদা হতে পারে, তো সেই সলিউশন গুলো কিভাবে পাবো?
ওয়াইসিটা আলাদা হতে পারে।
না মানে আমি বলছি ই পাওয়ার এমএক্স টা ট্রায়াল হিসেবে ইউজ করেছি, তো অন্য কোনো সলিউশনও তো ট্রায়াল হিসেবে ইউজ করে দেবে যেটা এক্সিস্ট করে, তো সেক্ষেত্রে ওয়াইসি তো আলাদা হতে পারে। এখানে ই পাওয়ার এমএক্স ইউজ করছি বলে একটা এরকম স্ট্রাকচার আসছে।
রিপ্রেজেন্টেশনটা আলাদা হতে পারে, বাট আলটিমেটলি দ্য সলিউশন উইল বি দ্য সেম, রাইট? আমি তোমাদের ডিফারেন্সিয়াল ইকুয়েশন যখন স্টার্ট করেছিলাম একটা পয়েন্ট বলেছিলাম, রাইট, যে কি whenever you are working out examples from any textbooks or exercises, হয়তো হতে পারে যে কি আলটিমেটলি তুমি যে আনসারটা পাচ্ছ দ্যাট মাইট লুক ডিফারেন্ট ফ্রম হোয়াট ইজ গিভেন ইন দ্য সলিউশন। ঠিক আছে? দ্যাট মাইট
হুম,
সিম্পলি বি বিকজ যে কি তুমি হয়তো একটা অন্য কোনো অ্যাপ্রোচ ইউজ করেছো, কিংবা সিম্পলি ইট মাইট বি যে কি তুমি হয়তো ইন্টিগ্রেশনটা আলাদাভাবে করেছো। ফেয়ারলি পসিবল, right? So it is just that the way in which the answer is represented might look different, but eventually it has to mean the same, right? যেরকম
হুম,
কোনো কোনো একটা কনস্ট্যান্টকে I can write e raised to the power something. I'm meaning the same thing, but I'm changing the representation. তো এখানেও সেম জিনিস। If you use some other trial solution, you will get the YCs and the YPs looking different, but eventually when everything comes together, they have to mean the same thing. ঠিক আছে? তো তুমি একটাই সলিউশনে, ইটস সামথিং লাইক সেইং যে কি, মানে when you are if you want to understand it in this way, দেখি আমার একটা সলিউশনের আলাদা আলাদা রিপ্রেজেন্টেশন বার করার দরকার নেই। আমি চাইলে
হুম,
করতে পারি, বাট আমার দরকার নেই। I can start with a different trial solution and try to bring it down all along and say যে কি yes, I am getting this kind of a solution, but eventually it has to mean the same. ঠিক আছে? তো যে কোনো ধরনের মানে ইউ তুমি যদি একটা সিম্পল এক্স স্কোয়ার কিংবা এক্স কিউব একটা পলিনোমিয়াল ভাবো, তো সেটা সেকেন্ড অর্ডার ডিফারেন্সিয়াল ইকুয়েশন এক্সিস্ট করবে, রাইট? সো
হুম,
if you solve it using this way, you will get the solution of that polynomial in a exponential format. That's it. Nothing more than that. ঠিক
হুম,
আছে? So exponential function has a flexibility যে কি, first of all, it all the derivatives exist and it can represent multiple formats. That is why you use this. Not the case that this is only way out. This is just to say that this is the easiest way out. আর কিছুই না।
হুম।
ठीक है सर, वैसा मतलब
हम्म
okay. Anyone else? Any other questions?
So that this is the exhaustive solution set. Like we have followed an approach since the beginning. We sort of
This is the
manipulated it in a way that we reached
exhaustive solution set. In what sense? I
in the
couldn't.
sense that we manipulated in a way that we reached the solution, e to the m1x, e to the m2x, and the linear combination of the two. But would there be any other possible solutions to this, with some other possible manipulations?
Uh, okay. So let's say that okay. How do I put this? Instead of an exponential, I'm not specifying anything direct, but let's say I have my homogeneous solution. Okay, sorry, homogeneous equation. And instead of taking very specific examples, let's say that it has two solutions, phi 1x and phi 2x. Okay, suppose whatever be the starting point, however we have got it, I'm not going into that part, but just saying that let's say that this has two possible solutions, two possible functions specifically as solutions, which is phi 1x and phi 2x. Can any of you take a guess and tell me that if I take a linear combination of these two solutions, will that be also a solution of this? What do you think? If I take C1 phi 1x plus C2 phi 2x, will this be a solution?
I mean, we can substitute and check.
Yes, definitely. Yeah. So what do you think? Let's work it out. It's not very time consuming over here. So if I'm saying that phi 1x is a solution, right? So that means what? Phi double prime x plus p1 phi 1 prime x plus p2 phi 1 x should be 0. And when I'm saying that phi 2x is also a solution, then this will be p1. Correct? So if I'm considering the linear combination, what will be the LHS? The second derivative will be C1 phi 1x plus C2 phi 2 double prime x plus P1 C1 phi 1 prime x plus C2 phi 2 prime x plus P2 times C1 phi 1 x plus C2 phi 2. Correct? This is what you're getting. Now if you just take this, take the C1 terms common. So what will happen to this? This part is also 0, right? From equation 1. And this part is also 0 from equation 2. Correct? So that means this will also be 0 and it is RHA. So that means C1 phi 1x plus C2 phi 2x is also a solution. Okay. So it need not actually even be exponential to start with. If you are able to find out any two possible solutions, then a linear combination of that will also be a solution. If instead of two, if you're finding more than two solutions as well, then also that will be a solution. Correct?
Yes. So the case we've handled where we get e to the m1x and e to the m2x, we're just looking for one of the possible images, or just one of the possible solutions, which happen to be the exponential
One
functions.
possible, so I'll stress on this word once more for all of you, one possible representation of the solution. एक solution को आप multiple functional forms में represent कर सकते हो, right? So we are basically looking at the exponential representation of the solution. Okay, I hope this makes things a little bit more sensible to all of you. We are talking about the exponential representation, right? Because you can basically change the representation of the functional forms, right? आप sin को cos के terms में represent कर सकते हो, log को exponential के terms में represent कर सकते हो. So we are only specifically looking at the exponential representation of the solution. Okay, is it making sense to all of you?
Yeah. And the reason is because this comes in handy, maybe that's why we're just focusing on that.
Yes, it comes in handy and it's easy to solve, right?
Hmm.
So basically if you think about it, trial solution is a starting point, right? So that means I can have any starting point depending upon the convenience, similar to the story of the integrating factor that we were discussing. So if you have to find out with rigorous calculation an integrating factor of a differential equation is not unique, right? So essentially, it's okay to find out any one of them. So if given a choice, which one would you choose? The one that is easier for you to calculate and find. Right?
Yeah.
So why would you want to go for the hard one? Correct. Not that you can't, but in the exam time, every minute you save is important, right? So why would you want to go that long path? Okay, that's the
Yes,
only
that
reason.
makes sense.
Okay, there is nothing more superficial to add on over here. Any other questions, anyone? Okay, perfect. So if there are no other questions, then let me stop here for today. We are not done with this discussion of the process. But in case if anyone has any questions up till this step, then let me know in the next class. We'll discuss this part once more or any other questions on the second order differential equations, and then I'll continue with the other cases that we are supposed to cover. Okay. So let's stop here for today and I'll continue in the next class. All right. Thank you everyone for joining. You all can disconnect. Thank you.
স্যার স্যার
Hi. Yes, yes. What's the question this or anything else?
something else.
Then just wait a minute. হ্যাঁ বলো।
হ্যাঁ, বলছিলাম যে স্যার এমনি প্র্যাকটিস করার জন্য ডিফারেন্সিয়াল ইকুয়েশনের কোয়েশ্চেন সেট বা ওরকম কিছু পিডিএফ কি আছে, মানে পাওয়া যাবে?
কোয়েশ্চেন সেট কিংবা পিডিএফ বলতে সব থেকে ইম্পর্টেন্ট রিসোর্স তো পাস্ট ইয়ার পেপারসই, তো ওটার উপরে ফোকাস করাটাই বেটার। আলাদা করে পিডিএফ কিংবা রিসোর্স এই মুহূর্তে প্রয়োজন নেই।
আচ্ছা। আর বলছিলাম স্যার গ্রুপ থিওরিটা কবে নাগাদ হবে? গ্রুপ থিওরি বা ওই ওই টাইপের টপিক গুলো, মানে অ্যালজেব্রা।
গ্রুপ থিওরি এখন টাইম আছে। গ্রুপ থিওরি সৌরভ স্যার কিছুটা করাবেন প্রথমে, বাট আমি এখন করাবো না গ্রুপ থিওরি। আমি এখন ক্যালকুলাসের পোর্শনটাই কভার করবো
মানে
ফর
আচ্ছা,
পুজোর পুজোর আগে।
এরপর পার্শিয়াল ডিফারেন্সিয়াল ইকুয়েশনটাও হবে, তাই তো? মানে
পার্শিয়াল ডিফারেন্সিয়াল ইকুয়েশন, ডিফারেন্সিয়াল ক্যালকুলাস, ওই পার্টস গুলো,
আচ্ছা
এগুলো আমি
আচ্ছা।
আগে কভার করবো।
হ্যাঁ, ঠিক আছে। আর আর যে ছোটখাটো টপিক গুলো আছে, নিউমেরিক্যাল অ্যানালিসিস বা ওইগুলো
ওগুলো
ওগুলো কি
পরের দিকে,
পরে
ওগুলো পরের দিকে, ওগুলো পরের দিকে ডিসকাশনে আসবে। এখন আমরা মেজর টপিকস গুলোর উপরই ফোকাস রাখবো।
আমি তো একটু লেটের দিকে ঢুকেছিলাম, তো মানে জানতে চাইছি কমপ্লেক্স অ্যানালিসিসটা কি হয়ে গেছে না চলছে, মানে মানে হবে
কমপ্লেক্স
কমপ্লেক্স?
অ্যানালিসিস আমি কভার করবো না, তুমি একবার সৌরভ স্যারের সাথে কনফার্ম করে নিতে পারো।
আচ্ছা আচ্ছা, ঠিক আছে।
হুম,
হ্যাঁ।
থ্যাংক